Alright guys, I got another call from my primary 4 student who gave me this question. Alright, okay, let's try this one. So we have Mr. Lee here gave some sweets to his sons. If he gave each son 9 sweets, he would have extra of 6 sweets. He would have 6 extra sweets, right? And if he gave each son 13 sweets, he would need 42 more sweets. This is a typical shortage and extra. Okay, let's try. So first and foremost, we just have to let the n be the number of sons that he had. So if one son gets 9 sweets, right, n number of sons will have 9n, right, number of sweets. That means the total number of sweets, right, will be 9n plus 6, because he has an extra of 6 sweets right now after giving away 9 sweets, right, to his 9 sons, right? Simple. Alright, that means we can draw the model. Okay, very simple model. We just get a simple model here. That means this will represent the total sweets, right? The total sweets. Okay, now the next scenario is where if one son get 13 sweets, right? If one son get 13 sweets, n number of sons will get 13n sweets. That means he need this 13n number of sweets. Yeah, but does he have it? No, he does not, right? Because he lacks 42 sweets, right? If he were to give each son 13 sweets, right? Okay, let me just draw a nice model for you. Okay, alright, that means this will be the shortage of 42, correct? Because he only have this amount, right? He only have that amount from here to here. This is the number of sweets that he had. Okay, therefore it means from one end to the other end will be 13n number of sweets, right? So his shortage of 42 sweets. Now that means we can combine them, right? That means in this case, this is the first scenario, this is the second scenario. The second scenario, right, we know that the total number of sweets will be equal to 13n minus 42, isn't it? Yeah, 13n minus 42 to get the one in purple, right? Okay, we have 13n minus 42. Okay, right? Let me just show you in color. This is your 13n from one end to the other, right? Then you have to minus the 42. He would need 42 more, isn't it, if he were to give 13n sweets to his children. Alright, that means we can combine these two, right? The total number of sweets, the 9n plus 6, right, will be equal to 13n minus 42. They are equal, they are the same, right? So this one you have to do it in algebraic form. Now, how are we going to handle this? We just have to look. The 13n is bigger than the 9n, right? So obviously the small one go to the bigger one. Alright, always remember that. And negative 42, we just move out to the left. So 6 plus 42 equal to 13n. Positive 9 bring over become minus 9n. Just like your 42 here, when you bring over to the left, it becomes positive 42. Always change the sign when you jump across the equal sign. That's the standard basic idea of algebraic equation. Okay, Alright, so it's very simple, don't worry, okay? Just a matter of getting used to it. Alright, so 13n minus 9n I can always put on the left because n is the one that we want to find, right? The unknown. Okay, we must know the number of n, right? Okay, so 4n equal to 42 plus 6 give you 48. It means n equal to 48 divided by 4. That will give you 12. That means he has 12 sons. Now, so from here we can know that we can find the number of sweets, correct? The total number of sweets. Yeah, we can use the 9n plus 6 or 13n minus 42 because they are still everything the same. Therefore, total number of sweets will be equal to 9n. If I use the first scenario, 9n plus 6, right? 9n plus 6 equal to 9n. N is what? N is 12, so multiply by 12. Okay, 9n means 9 times 12. Okay, so 9 times 12 plus 6. Alright, so 9 times 12 is 108, and plus 6, that will give you 114. That will be the total number of sweets that he had. Okay, so it's very simple, isn't it? That's all, folks. Thank you very much. Take care.